Hi, this is Ning Jiang. Thank you for joining us in the morning for this webinar. Let me know if you can hear me. Okay, so forecasting is quite an exciting topic and a critical part of any business in retail or consumer packaged goods. It's used in many applications, for example, for supply chain, for revenue management, for human resources planning or capacity planning, or for procurement, for replenishment. There are many applications of people give them different names, but fundamentally, at the technical level, they are very similar to each other. So today, we are going to talk about the new technologies made available by AI in the last couple of years, and how that could have changed your forecasting, and how that would benefit your get you higher forecasting accuracy than ever before. My name is Ning Jiang. I'm the CTO of OneClick.ai. OneClick.ai is a deep learning or AI platform that we build, and it's the only fully automated AI platform that supports deep learning. I don't know how many of you have heard deep learning technology. It's a technology that has revived AI in the last couple of years, put AI back to spotlight. The reason we started hearing lots of news about AI is basically due to deep learning, because it enabled us to do lots of new applications and do existing applications at a level of accuracy that wasn't possible before. Like 5 years before, a lot of things we can do today wasn't possible. So what we are going to talk about today, we first will go through the fundamental limitations of existing approaches. Those approaches are basically based on statistics and developed like at least 10 years ago. Then we will explain the challenges that you need to address in order to improve your forecasting, assuming you already have used the solution using existing technology. And those challenges can be addressed by latest technology, basically by using deep learning. But using deep learning is a complex, really complicated thing. You really need to have expertise, design customized deep learning models, which is neural network, in order to take the advantage of technology. Lots of people, businesses don't have that resources or time or skills. So what they can do is to find pre-built solutions. So OneClick.ai offers such a solution using deep learning to build customized forecasting model for you so that you don't have to. So later, we will give you a demo just how to do it. It's like a 10 minutes demo that would allow you to benefit from the latest technology. We will have some time for questions in the end. But feel free to interrupt me, drop a question in the chat window. So we know the traditional approach, for example, ARIMA-X, and running average. There are lots of other approaches, but they all fall into the same line. They are basically called linear algorithms. Those algorithms were developed by statisticians. The reason they called linear algorithms is basically what they assume a time series sequence can be divided into a few components. And each component itself is a time series sequence. For example, the sales numbers, the sales volume, and the components we're talking about here can be, for example, seasonality, the impact of a sales event, a promotion, or just and one of the components can be just the average sales volume. So the basic assumption made by traditional approach is that those individual components can be linearly added together. And the sum of all those components should be close to the actual sales number. But we actually know it's not the case. Just for example, if you have sales events on weekday, on a normal day, you may have your sales volume, let's say, increased by 40%. And during the weekends, your sales of some products may increase by 20% by itself. So if you run your sales events on the weekend, it does not necessarily mean your sales volume going to increase by 60%, because they don't just add up. You can replace the sales event by with, for example, holidays. The holidays and the weekends don't add up together linearly, because it's the same day, very likely it's the same set of people visiting the store. So you don't see the benefits doubled. That's because this wrong assumption. Often, traditional statistical models like ARIMA-X won't be able to fit your data very well. So it won't be able to capture the pattern and relations between those individual components. And even worse, typically those components have to be manually defined. So you have to be able to understand all the potential patterns that are going on in your time sequence, and which is very hard to do, because you basically do it manually based on your domain knowledge, based on your own experience. The other problem is because all the traditional approach has been seeing each product, for example, could be product or product location combination or other thing. Basically what we call a time series sequence. Traditional approach has been seeing each product as an independent thing. When it's trying to learn or predict for the sales of one product, it never look at other products. That's what I mean by independency. But there is a huge problem when you, let's say, trying to predict the sales of new products. They have no history or very short history. And from very short history, there's no way you can observe patterns and believe the pattern can be extended into the future, because there's no way you can tell apart the patterns that hold true for a long time and just random events, because we do know sales has fluctuations. So that makes it very hard to deal with new products. For the same reason, because we are seeing each product independently, you also cannot observe or model the impact of one product's sales on other products. But it actually happens. Think about if you run one brand of yogurt in your store is running a sale, running promotion. The yogurt of that brand has higher sales volume. But what's going to be the impact on other brands? The chance is their sales are actually going to be reduced. And if you only look at the other brands alone, you won't be able to explain why the sales dropped, because you don't even look at the sales of other brands. You only look at the sales of this one particular brand at a time. So it's something traditional approach has no way to deal with. That's why basically we need to use better technology in order to solve those problems. So in the rest of the talk, I'm going to discuss 10 fundamental challenges that existing technology cannot address. And all those problems can be addressed using deep learning. If you have ability to develop customized deep learning model for your business, then those problems can be solved very well by today's technology. If you can't do it yourself manually, OneClick.ai do offer products that allow you to do this fully automatically, so that you don't have to worry about how to implement the deep learning technology for your organization. So let's look at those challenges, and it's your call to judge whether those challenges hold true for your businesses. So let's talk about holidays and the planned sales events. Traditionally, when we deal with holidays in sales forecasting, what we do is we create indicators on the holidays or the sales event days. And that indicator will help you just increase the sales volume that you are predicting. For example, at Black Friday, you may project that your sales increase by 100%. And or with certain promotion going on, you may project this product sales, individual product sales may increase by, let's say, 20%. That's what you end up with. But clearly, we are making a strong assumption that the impact on the sales only happens on that particular day, on that holiday itself, and or on that sales event day or week, which is not true. So let's see an example. So we plan to have sales event on week 7. But starting from week 3, we start seeing a drop in sales. Why this could happen? Because your customers, whether it's end consumers or they could be your distributors, they start anticipating the sales event. And if I don't need the products right away, I can hold off my purchases and wait until week 7 so that I can get a lowered price. That makes sense for any rational buyers. So, and when it's getting closer to week 7, the benefit of waiting is increasing. So you see, when you getting closer to week 7, your sales dropped further. That, to some degree, actually cancel out the benefit of sales, of running a sales event. So this cannot be modeled by today's, let's say, today's traditional technology, because basically it's quite difficult to figure out basically how people respond to, let's say, at a specific time. For example, 1 week ahead of the sales event, 2 weeks ahead of the sales event, how people respond to them, how much impact it has on the sales, how much job it has. It's kind of difficult to learn, especially if you assume a linear model. That's something we basically can't learn. After the sales events happen, it still have impact on the sales. The sales won't go back to the norm immediately. And here's an example. So on week 1, in week 1, we had a sales event. A typical case is because consumers have bought what they needed. And because they know there was a sales event, lots of them are willing to buy the stuff before they need it. And because of that, in the coming weeks, there are fewer consumers that are going to need to buy your products because their needs for the product has been fulfilled earlier. This is true for for anything that can be, let's say, kept in the house for a couple of days or a couple of weeks, as long as it's not going to get spoiled. So that's why basically you from the week 2, you see a big drop in your sales. The sales will gradually going back to the norm in the coming weeks eventually. But again, this cancels out part of the benefit of the sales. And it makes things very difficult to forecast just based on historical data, because traditional model cannot capture this. And this is not something you can easily model by hand. So we'll talk about how to do those things using the modern technology. But fundamentally, if you see this kind of pattern across many products, it's possible using today's deep learning technology to learn how much impact it has for the following weeks, how much impact a sales event may have to the weeks before the event. You cannot do that based on a single product. But if you see all the products collectively, you can see that this pattern happening many, many times at a different time in the year. So that will allow you to find the pattern, and quantify the impacts. So the third one is about sales cycles. Especially when you are working with distributors or franchise stores, you define sales cycles. For example, sometimes it's based on year, it's yearly cycles, sometimes it's monthly cycles, or a combination of them. So those cycles typically relate to the commissions you give to the salespeople, and you set the practice is set quota for salespeople, or for your distributors. If they can meet the quota, you give them certain commission, or they simply give them a discount in the price. So the salespeople and your distributors are motivated to meet your quota. So the incentive to do this so that you can increase your sales. That's the original purpose of this, but it also has side impact. So look at this. Because your quota is fundamentally based on your forecast about the future sales. So what if you somehow overestimated the sales and make it very difficult for the salespeople or your distributor to meet the quota? And because of that, they are not going to get the discounts they wanted. So the typical response we have seen from our own research and from our customers is if it's within a reasonable amount that they can afford, the distributor going to pre-order products before the end of the sales cycle, so that for this particular sales cycle, they can meet your quota. But it not necessarily mean there's demand for those products. They may not be able to sell those products, but they can hold them in stock and wait for next sales cycle to sell them out. And hopefully next sales cycle, you have more reasonable quota set. This is fundamentally because the current forecasting approach taken by businesses are not accurate enough. So your forecasting sometimes higher than the real demand, sometimes lower than the real demand. So by pre-order products, they can smooth it out, but they also can get the benefit of a discounted price. That's why basically you see here in this chart, I'm assuming the sales cycle is monthly. So you see by the end of the month, you typically see a spike. That's basically when you set your quota too high. But what if you set your quota too low? So that your salespeople or your distributor can easily meet the requirements. They already got a discounted price. So there's no benefits of selling more or working harder to get people buy it. So, and sometimes they can easily, but the customer still going to come to them and order they will still want the products. The demand is there. So, but to their benefit, to your distributor benefit, it's better to defer those purchases to next sales cycle. Because next sales cycle, you might set a quota that's too high to reach. If they can defer the exercise sales to next month, it makes next sales cycle easier for them so that they can get discounts this month and the next month. So that's what's going to happen here. Sometimes this deferral is due to default reporting. Sometimes they really talk to their customers or downstream distributors to actually defer the purchases. They can sometimes they even lend the products to them, but defer the purchases to next sales cycle. That typically causes fluctuation in the historical data and make future forecasting even harder. So the model must be able to capture this kind of thing, understand the potential impact of sales quota, and be able to observe actual sales quota you set to model this behavior so that we can actually predict actual demand. Because in the ideal world, you don't want to predict the behavior of your distributor or because they are gaming your system. You want to predict the actual demand, only actual demand that can be learned and follow certain patterns. Human behavior here kind of introduce noise, random, as to some degree unpredictable. Sometimes your competitors, for example, a store nearby your store, going to run sales. And those sales, quite just like holidays, will affect your sales also. At least if you have some products related to what they are selling. So traditionally, people only deal with holidays and their own sales events, basically planned sales events in their model. But really, you need to also model competitors' sales events. And those competitors can be, for example, online stores, for example, Cyber Monday, or sometimes they call it Cyber Week now. They work against, if you run a multi-store, those online sales events also work against you. They take people away from, the hassle going to your store. They just order it online. Or they go to your neighbor stores because they are running sales for the same products that you are offering. That reduces basically the demand for your products, and you'll see a drop. In order to capture this pattern and explain it, you have to provide your competitors' sales events, and that information is critical. Also, to make things more complex, if we have ability to observe the sales of multiple products, you will start to see some products sales increase for some reason, for example, promotion or a price change. And those things will cause that product to sell more or sell less. But this kind of change in the sales actually going to affect other products, at least the products of similar types, the products that are going to be bought by the same set of people. Unless the price change is really huge across the board, the the need for one type of product is to a large degree fixed. So there are competition between products of a similar type or similar functions. You see in week 2, I think I called it the darker blue brand A. The brand A sales increased because we are running, and the brand is running a promotion. You got a discounted price or buy one get one free. But other brands of the same product going to see a drop in sales. After that week, the sales can go back to norm pretty quickly. But you have to, your model, in order to predict predict the sales accurately. When you predict the brand B in sales, you have to take brand A sales into account and also take into account the promotion you are running for brand A. That makes things quite complex. Don't even think about doing it manually. It's really, really hard to model. Well, deep learning can achieve that. Also, think about basically how you can tell one product sales may affect the other product sales. As we mentioned earlier, we assume those products must be in the same category, serving the same needs, providing same functions. But how do we know that? Typically, in the sales historical data, what you have is, for example, SKU and their sales volume by days or by week. So if you have enough historical data for those two products, you might be able to observe the pattern. The historical data is long enough for you to observe pattern that when there's a sales in one product and the sales going up, the other product sales going to drop. When you see that pattern repeatedly, the AI algorithms can learn it. But what if this historical data is not that long? For example, it have just 1 year of historical data, and you just run 1 or 2 promotions in one product. So that makes it really hard to confirm the pattern is really a pattern instead of just a random fluctuation. So to make it easy, we often ask our customers to introduce intrinsic characteristics or product attributes. Those attributes describe what kind of product it is. Help identify products that fulfill the same function or needs. For example, this is just a simple example I have taken from Amazon. So you have 3 different SKUs. The first, they are all soft drinks, and the first 2 would supposed to taste a lot similar. And there are different brands and different packaging, but the container size is similar, and both don't have caffeine. The price also, there are also difference in price. So some of the similarity, for example, container size is the same, and they may taste similar. Though there are different brands and different packaging size and a different price, per unit price is almost the same. So there is some similarity there. There are some differences there. A good model should be able to learn that whether the similarity is enough to cause their sales to compete with each other. That signal, combined with historical data, you still need to see in historical data that this product indeed compared with the other product. But with this signal, you can easily isolate products that compete with each other and the products that doesn't. So it makes things easier to learn and easier to confirm the pattern. So those additional information can be very critical if you are dealing with if you are selling similar products of different brands or different flavor, which is not taken care of today by most businesses and people doing forecasting. So another scenario is when sometimes you have relatively short historical data. With that, it's very difficult to tell when you see a spike in sales or a sudden dip in sales, not corresponding to any sales event or holiday or other special events. Then you're wondering whether this is just a random event, fluctuation, or it's a new pattern. It's quite difficult to confirm that using traditional approach, because let's say with 1 year of sales history, this spike only appears once. There's no way you can figure out it's a pattern or not. But using today's modern technology, you can deal with multiple products at the same time. You observe across those products on that particular time, the sales all increased. Or a subset of your products had sales increased. This gives you a clear signal. This is a pattern. There's something affecting your sales and causing the sales to go up. So this pattern, if associated to the certain time, for example, associated to events that regularly happen on month 8, then it may repeat in future, in next year. That's basically how you can learn a pattern. Even the pattern only appears once or twice, but it appears in multiple products. So ability to observe patterns across many products is critical if your sales history is not long enough, or if your new patterns comes and goes. And if you have new products, or products with very short history, just a couple of months of sales, and you're predicting next month, but the product hasn't been sold in the corresponding month last year. So it's kind of difficult to predict that based on the history of this specific product. But if you know this product is similar to other products based on the descriptive features or attributes you know about the products, you can believe that the trend and the growth of this product sales might be similar to similar products that has been sold before. Then you can look at the sales history of the similar products that had longer sales history and copy the same pattern there to the new products. That's what's happening here. The light blue one, part of it is covered by the yellow. Basically, I assume the yellow is kind of average, the average sales throughout the year for products in that category. So product A was introduced in month 1, basically in January here, and it takes about 2 months to convert to the norm, to the average of that category, and then it follows similar pattern. If you have product B of the same category, and you don't have much sales history of it, you can expect, because the fact that they are in the same category, the sales of product B will follow the same pattern as the product A. So it takes So here we assume it will again take 2 months to get into the norm. So the first month, what I said here is basically first month, you got about 30% of the normal sales volume, and the second month you got about 60% of normal sales volume, and then in the third month, everything is normal. So there is a growth pattern that to some degree holds true for all the products in that category. If you have ability to look into multiple products or the products in the same category or other, it can be, you can define similar products in many different ways. By category, by flavor, by brand name, or that type of thing. And then see them to have a similar pattern. Then for the new products, because they are in the same category with the same flavor, then the chance is that pattern still holds true for the new products. So you will just do the calculation and assume it's going to get to the norm in 3 months. That's why basically that's how we derived the sales of product B from product A. This is something, again, not supported by any traditional approach, but with deep learning, it's possible to model this. Again, in some industry, the sales of product has a life cycle. For example, electronics or phones. So the performance of your phone when it's introduced was great. People loved it. But after 2 years, the performance of the same configuration is considered too slow, not supporting the new applications. So the sales of it is going to drop significantly. That's why you see a sales cycle here, the life cycle of a product here. You can find many examples of that. But in order to see the impact of life cycle, you have to observe multiple products again. If you only look at one product at a time, for example, if you only look at the sales history of product B in the last year, what you see is the increase of sales. Because it's newly introduced product, it's getting more and more popular. But unfortunately, unless you observe similar products in the same category and learn that their sales start to drop in the second year, you would assume the sales of product B, product A to continue grow next year. That's what this chart suggests without looking at the sales volume of product B. So again, this tells us it's critical to observe and learn patterns from multiple products at the same time. And the multiple products, and also look at, remember this, the sales cycle for each product begins at a different time. Here, actually, I set them to all begin from Q1, but not necessarily true. What if you introduce a new product at Q3? That will actually make a difference because seasonality itself. So the life cycle is one component of this, but in the same time we observe this, you have to observe other components. That's what makes this really difficult. So what's the solution? So deep learning today allows you to model and to observe multiple products at the same time. And it can deal with products with longer and short history. It doesn't have to be the same length. And it can use a single model to deal with all the products at the same time. Those are great properties that a traditional approach don't support. So, but developing your own deep learning model for sales forecasting is actually quite complex. Sales forecasting technically can be considered as a regression problem, but it's a lot harder than traditional regression problems. Traditional regression was, in statistics, traditional regression was a well-solved problem, let's say, about 50 years ago. But most approach, so-called statistical approach to forecasting was introduced in the last 10 years, more like last 10 to 20 years. So just from that timeline, we can tell forecasting, because it's dealing with time sequence, is a lot harder than traditional regression problem. And developing deep learning model for that is even harder. So we have developed a solution at OneClick.ai to automate the model design for time series forecasting. And sales forecasting or demand forecasting is one particular application of our technology. This technology is not built for specific industries or verticals, because we use something called automated machine learning technology that allow us to design highly customized algorithms, just like a human data scientist would do. So it examine your data and come up with initial model design and test it out to see if that design, if that algorithm works well on your data. If it doesn't work well, we will take the feedback and improve the model, improve the algorithm, and then we will try it again. So we do it iteratively, just like an experienced data scientist would do when it comes, if they're doing it manually. Except this all happening fully automatically. And because it's all done fully automatically, you don't actually need to understand why deep learning works, how to make deep learning works, how to make deep learning works on time series data. You don't need to worry about that. Just throw your data into our platform, and the model will be designed and iteratively improved. And the best of it, every model is customized designed for your data. So that allows you to put almost any kind of data, any kind of information into your data. So that from our side, it basically means we can deal with all kinds of information. And with sales history, longer, shorter sales history, product description, promotions, and we can observe patterns across different products, patterns that happen at a different time, and the patterns that are changing over time. And we can recognize what's fluctuation, what's real patterns. So just to give you an example, the kind of information you can provide into your data that help you solve the problems that we just talked about. Typically, if you are just doing sales forecasting for products, you have a column called SKU that identifies individual products. And then you have the actual sales amount as another column. And of course, you need to have a date column. So those are the essential 3 columns that you have to provide. But beyond that, you can also tell us, give us a description of the product and other things like brand name, the package size, container size. Those things help us capture the differences or similarities between products. And also about your sales activities, you can describe your what kind of promotion you're running, what the price you set the product for, and maybe sales channel and sales quota, all that kind of stuff can be put into this data. And as you can see, the data can be in the form of numerical data or simple plain text. So we'll figure out how to use those things, those information automatically. And you don't have to worry about that. So let me do a quick product demo. Let me know if you have any question. I'm starting the video just in a second. Okay, this is, if you go to OneClick.ai website, this is what you are going to see. And you can sign up for a free account. So now I'm logging into our website. You are going to see our studio page here once you log in. What you see to the left-hand side is a list of projects you are working on. In the middle, you see a conversation window. It has a chatbot that allow you to ask questions about your data and the model you have built. You can compare the model performance, for example. And to the right-hand side, what you see a list of models you have trained and the list of data files you have uploaded. So that you can manage them, you can delete them, for example. So what you do is you create, because this is a platform that build a customized machine learning model for you. So in order to do that, you have to upload your own data. So assume you already have your own data. So all you need to do is click this button and upload. So this platform actually supports more than just sales forecasting. It supports common tasks like classification and regression. And it does support all kinds of inputs, and even you can even mix all kinds of inputs together. For example, you can build a classification model that handles image, text, numerical data all together. Often, and it does support image classification, for example, because image classification is just a special case of classification where the input data happen to be a single image. Well, we support a lot more complex scenarios. Sales forecasting is one of just one of the three scenarios that we support. The three scenarios are classification, regression, and forecasting. So for because today we're only talking about forecasting, so I'm going to focus on the forecasting part. So let me so this is the forecasting data I'm going to show today. It's released as a public data set released by Walmart in 2013, I believe. So this data is fairly simple, a lot simpler than the data that we have seen our customers are using. What you have are 4 columns. The first column is store ID. Second column is department ID. The third column is the dates. They have one date for each week. And the last column is the corresponding sales for that week. From this, you can, let's say, you can forecast based how much sales each individual store may make in the next 1 or 2 weeks. Or you can predict the sales of each individual store and department in the coming weeks. So the data looks fine to me, and so I go to next step to tell the system what I want to predict, what I want to forecast. So here I'm going to select I'm going to forecast, because I'm going to select weekly sales, because that's what I'm going to learn to predict. Yeah. And the type of application we are building is forecasting, because we are predicting the future in timeline. So you need to select the metric, and the metric tells us how we can evaluate the quality of the model we build. So you have to provide that information. Then you tell us which is the data column that by which you sort all your transactions or historical records. Sometimes you may introduce multiple data columns. For example, you may have a data column to tell us when the product is first introduced to the market. That could be very useful information, but it cannot be used to sort historical transaction. That's why you have to make this choice yourself. And also reporting columns, because the sales volume can be aggregated at a different level. And knowing that in advance help us predicting the better. So it can be individual stores or individual store department combinations. And finally, the last 4 rows allow you to tell us what's the time range or time ranges you want to make forecast for. Those time ranges can be individual time ranges, or they can be even overlapping time ranges. So we allow many different ways to define those time ranges to suit different applications. So once you select those information describing what you intend to do, all the rest is done automatically. So I'll skip the rest of it, go straight to basically the forecasting results. So if you wait about 10 minutes, because this is a relatively small data set, so if you wait about 10 minutes, you will see the forecasting results produced as a file that you can download. And this is because, so our platform do support other ways, for example, to use the model. For example, you can access it through API, which you can deploy just by clicking a button. Or you can access our models by uploading a file and ask the EVA or chatbot to process the data for you using the build model. It will process it without writing a single line of code. But for forecasting, you already told us what you want to do. The time range and the reporting columns are all set in the setting page. So we can produce the results that you want right away. And you can just download the file. Let's take a look at it. This file is very simple. It's called CSV format, plain text format, that can be imported into database and loaded by Excel, and it can be visualized easily. The information here is fairly simple. So it tells you the time range from this particular time to this time. And this particular store had this amount of sales. That's it. That's very simple. We have only one store column without department column because we selected the reporting column to be store ID. And that basically is telling us to aggregate our sales by stores. That's why basically you only have store ID here. You don't have department ID. That's basically, so this is basically a very short and simple demo about the sales forecasting. In reality, as we suggested earlier, you can add other information, other columns into your data, so that you can improve your sales forecasting. Just me showing here. For example, here if you insert other columns that describe that tells us the SKU, individual products SKUs, and their description, it's actually going to help you predict the sales better. Because without knowing individual product sales, we can only see the overall trend of a store department. And sometimes it's the real pattern for individual products is hidden when you combine them together. And you cannot know that some product sales is going up, some are going down. Because when you combine them together, those sales volume change may just cancel out. So you see kind of static sales numbers, but which is not the case because in next month, some products will continue to go up but the dropping of some certain products sales may stop at somewhere because, for example, that's it's the end of their life cycle. It's not going to drop further because it's already reached zero sales. So giving additional information or fine-grained the data may help your sales forecasting further if you're using this platform. Okay, so that's the product demo. So let me know if you have any questions. And I highly encourage everyone to go to our website to sign up for a free account. And if you do in the next few days using this particular code, you'll get extra tokens, basically, which means more computation resources assigned to you. Let me know if you have any questions. The question is, what makes OneClick.ai unique? Well, there are many other AI open source library in the market. Especially what makes your company experienced in the retail demand forecasting. Okay, so what makes us unique is among all the open source libraries, you won't be able to find anything that works for time series data and using deep learning. We are the only one, actually. So across all the commercial products and the open source library, we are the only one that's supposed to allow you to use to automatically create deep learning models for time series data. Most of the things that we have done theoretically can be replicated by very experienced data scientists. If they have ability to write a machine learning model, deep learning model, and are familiar with time series, so it's possible to do it manually using open source library. But those libraries are going to be something like a TensorFlow. So basically, you have to design your model from scratch. There's no existing package that allow you just to feed data into it and produce results for you. Deep learning is not like a traditional machine learning approach. It's to use deep learning, you actually have to design your neural network, design its architecture. And because the time series data is kind of complex, it cannot be dealt with traditional deep learning, traditional algorithms at all. And there's no pre-built, commonly accepted solution to it. You have to customize your algorithm, your deep learning model. Our experience, we become experienced in, let's say, sales forecasting or just the general forecasting algorithms, because we have been working on this over a year, and we have seen, and our system has learned from many data sets uploaded by our customers. Our platform is built around technology called AutoML using deep learning, or you can call it AutoDL. DL stands for deep learning. So it basically learns to improve itself. When it sees different data sets, it designs different models and trying to improve the models iteratively. In this process, it learns for what kind of data sets, which kind of model works the best. So this is really works just like a data scientist. The particular algorithm we are using called reinforcement learning that will allow us to take the characteristics of your data set and translate that into optimized model. So this ability allows us to learn from all the models that we have seen, all the data sets users have uploaded, without even keeping the original data. That's basically how we gradually improve our system over time. Because when more and more customers using our platform for forecasting, they upload their data, and we learn which kind of model works the best. Okay, next question is, can the OneClick AI be customizable if we want to use a time series model and not consider other attributes? Yes, of course. So all the attributes I talked about in the presentation or in the demo are optional. And it doesn't have to be that name. You just add, so the basic 3 columns are needed. There are basically 3 columns are needed. The number 1 is the date or time. Because this time series data, I need to know the history when each transaction happens. We need to know the order of them. And this other column is the product, typically the product. Actually, even product or SKU is optional. If it just has only 1 sequence, you don't necessarily have SKU. And the other column you typically have is the sales volume. That's the only things you must provide. Any other attributes about products or about your sales activities are just optional. The question is, can OneClick AI consider external factors like weather or tourist footprint for a particular location? So yes, we can. The way we do it is, except for holidays, we have built-in support because it's corresponding to the time or date columns that you specify. But for the other information, we ask our customers to provide. For example, you can just simply add a column, tell us the temperature. If you are selling drinks, it's going to be affected by the temperature a lot. And we will automatically learn that your sales history is somehow correlated to the temperature. So the model will take that into account. Right now, the platform has one limitation, that for forecasting, we don't support API yet. That basically means you cannot tell us in the future what's going to be the weather or temperature. Actually, because the temperature or weather itself is unpredictable, and especially for longer term, basically, for periods over 3 days, you cannot forecast the temperature or the weather conditions. But there are other things that make sense to provide. For example, if you have planned sales, let's say in next month, and on the particular day next month, you may want to tell our system that what's going to happen, and that would influence the results. So that to support that, we need to provide the API to the model, and we are developing that functionality right now. You should see that ready in 1 or 2 months. But even without the API, our customers have seen that typically just switching to this platform, they can improve the forecasting accuracy by 10%. And right now we have a good number of large enterprises operating on our platform. Thank you for joining the meeting again, and hope you. Okay, sorry, one more question. If we need to use OneClick AI to test and see if it's usable for our company, do you have a demo period? So we do and we don't. So you can go to our website and sign up for a free account, and you can use it anytime. We'll put some credits into the account automatically, and your trial period ends when the credits runs out. So again, so if we want to sign up on the platform, I would recommend to use this promotion code November-webinar. This code would give you additional credits so that you can do more experiments on the platform. And if you run into any trouble using the platform or need our support, feel free to reach out. So I'll type in the promotion code here in the chat bar, in the chat window. So this is our promo code for green account. We don't set a time limit on the account, so you can use it anytime you want once you sign up. Okay, thank you everyone for joining us, and we will regularly do this kind of webinar. We have two sets of webinars, so some of them are technical, some of them are non-technical, business-oriented. This one is one of the business-oriented ones. So you're welcome to join our future webinars, and we also host meetups from time to time. So stay tuned. If you go to our website and you sign up for a free account, you will see a notification that we send you when we have new events. Anyway, thank you for today, and have a good one.